Good. Good morning. Anyway, all right. No, watermelon, right? Okay. 1.3 continuity, AP calculus 1, right? Not 2, 1. All right. So determine whether a function is continuous at a number. Determine an interval in which a function is continuous. Use properties of continuity and intermediate value theorem. Okay. First, let's do some like rehearsing. You guys ready? All right. Get your arms ready for this. All right. Okay. Get your arms ready. Okay. You ready? Okay. Got to get your arms. You ready? Okay. All right. For a limit to exist, what has to happen? Show them with your hands. What has to happen for a limit to exist? Yes. 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 Sure. No, not MCA. Come on. Yes. Okay. What you got? Yes. Okay. For a limit to exist, the left hand and right hand both have to go to the same point, right? Okay. So, now, give me an example of one that the limit does not exist. Come on, hands. All right, right? Yes, very good. Okay, where they're not going together at the same point, right? Okay, that's called a discontinuity there, right? So it is going, but it's the X, there is a gap there. It's not continuous. So think of it as you're riding a roller coaster and all of a sudden the track is no longer there. Okay, it's not continuous, right? Yeah, get kind of scary. All right, so definition of continuity at a number. A function is continuous at a number C following these three conditions are met. F of C, what does F of C mean? The function, what do we do with it? You plugged in C, right? And C is normally referring to my point that I'm trying to find it, right? Okay? Glazed over there. All right, so right here is defined, that is, it's in the domain of F, okay? Right here, next one. The limit as x approaches C, f of x exists, okay? And the limit as x approaches C of f of x is equal to f of C. So now, what does this mean that if the limit is equal to f of C? That they do meet, right? Is there a hole right there where they go together? Say no. The limit, remember the limit occurs when both left and right go to the same number, right? Okay, does that number have to exist? No, there could be a hole right there, but both left and right hand go to that. Yes? Now, what that last statement is saying, my left and right hand are both going to that number, and f of C is that same number. Okay, here's examples. Okay, if you guys can see this right here. This is right here at C, and this is f of C. There's a closed dot right there, so that means what? Closed dot. Right on my function, right at C. It is meeting there, right? It is existing there. So it is there. So the left hand and right hand both go to that number, and the number is right there. Okay? Now, this is where the left hand, right hand both equal, and it's equal to f of C. Yes? I'm throwing out all kinds of letters, so let me know if I'm going too fast for you. Okay? Next one right here says, if you look at right here, on f of x right here, I have a open dot right there, don't I? But there's a closed dot down here. So what does that mean? What does that mean? The limit exists, right? Left hand, right hand both go to that, so the limit exists. Okay? So now right here, both left and right, but it's not equal to f of C, right? Because f of C is the closed dot. If you look, the closed dot is down here. So, is this one right here going to be continuous? Think about it. Roller coaster. If you see a jump in the roller coaster, like there is missing a piece of your roller coaster. Is that continuous? No. Okay. Does that make sense? Yeah, it makes you pretty scared seeing a hole in your roller coaster, right? Okay, all right. Next one over here. Now, this is right here. Is there anyone or anywhere here? So there's an open dot there. Is there anywhere that this is a closed dot on that line? No. That one's a hole right there, right? So it does not exist at that point, at that C, right? So, but the limit exists. The left hand and right hand both go to that same point, right? Yes. But f of c is not defined. It's undefined, so it's not there. Okay, so if you were to plug in c into your f of x, you would get undefined, right? Not existent. Now, this next one over here, okay? So, what do I say wrong with this one right here? It's not continuous. Left hand and right hand don't go to the same point, do they? So, the limit does not exist, right? Because left hand and right hand both don't go to the same point. So the limit does not exist. Now, over here there is a closed dot right there, okay? Closed dot right there. So, is f of c defined? Yes. So f of c is down here. So this is wrong on just about all points right here. So f of c is not equal to here, and the left hand, right hand both don't go to the same point. So this is a no. No. Okay. Fifth one, that's where we're at. 5. Okay. Left and right, do they both go to the same number? So does the limit exist? No. Is f of c defined somewhere there? No, it's not defined. There is no closed dot there. So it is not defined. Does that make sense? Are you guys okay? Kind of? Okay, so like I said, if you're having trouble, speak up. I will go over it. Okay. So, determine whether this function right here is continuous at 1. Okay. Determine whether it is continuous at 1. So, check it. You guys got some problems here, right? Okay, a couple ways I could check this is what? You can graph it, right? Y'all got calculators. Come on now. Don't you go getting all cattywampus on me now. Does it exist? What'd you say? What did I show you the trick with the calculator the other day? No, you don't have to. Alright, so 3x squared minus 5x. Okay, so let's see. 3x squared minus 5x. What's the last one?
Plus 4.
Plus 4. Okay. There you go. Alright, so there's my function. Okay, here's 1, right?
Yeah.
Okay, let's try this. Class.
Yes.
Now that got your attention here, right? So, is the left hand and right hand both going to the same number?
Yeah. Yes.
Look at both sides of 1. Is the left hand of 1 and the right hand of 1 going to the same number?
Yeah.
Yes. Now, f of c. So now we're going to test to see if it's at 1. Now, here's the trick I was showing you the other day. Okay, so right here, I know everyone's looking up here because this is the trick. Menu, trace, graph. So we could actually arrow over to see where it's at, right? Now, once the trace is on, you could just hit the number 2. Watch this. Or wait, 1, right? We're testing at 1. Hit the number 1. It brings up a little box. X equals 1. Hit enter. Hey, look, it is there. It does exist, right? So this one does exist. So is the left hand and right hand both going to the same thing? Yes. Is the limit equal to f of c?
Yeah.
Yes. Very good. So yes, that's what I'm looking for. So this right here, so this one's going to be yes. And for this one right here, so the limit as x approaches 1 of my f of x is, what was the limit?
2.
It went to 2. Okay. There we go. All right, so now let's check the other one. Now, looking at the problem in the first place, does it look like I'm going to have an issue?
Yeah.
Why?
Because it's a fraction.
It's a fraction, and what can you not have in that fraction?
Negative?
You could have negatives.
0.
0 where?
Minus 2.
0 in the denominator, right? I'm not allowed to have 0 in the denominator, right? So I can't have 0 here. So if I plug in 2, I get 0 in the denominator there, right? Okay, so now can I remove the discontinuity here?
Yeah.
X squared plus 9. Can you factor that? Say no. No, you cannot factor it because x squared plus 9, you can't factor. An x squared minus 9 is a difference of squares. You can factor that. But with the plus sign here, you can't factor that one more. So let's go to the calculator and see what the calculator says. So tab up. Now, for you people new to this calculator, take a quick look. Hey, you people, pay attention. Okay, control, divide. I try not to say names during the video. So this is going to be
Cash Caldwell.
x squared plus 9 over x squared minus 4. So the control divide brings up a fraction thing here, so it actually helps us out. Hit enter. Ooh. And where am I testing it at? 2. Alright, so is the left hand of 2 and the right hand of 2 going to the same number?
Yeah. Just kidding.
This is recorded. Other people are gonna like watch this. I got people from like other parts of the country actually watching these. Yeah. Other side of the country, not other countries. Anyway, but still. All right, so now right here, the left hand is going down, straight down, right? And the right hand is going straight up. What would that be right there? What would you call that? That is a discontinuity. What exists right here at positive 2? What exists at positive 2? I heard it. Asymptote, right? Okay, it is an asymptote here, right? Asymptote. Left hand and right hand both are not going to the same number, are they? No. Okay, so that takes care of that. Now, so is it continuous through here? No, it is not. Okay, so now I'm going to turn trace on so I can show you again. Oh, wrong one. Trace on. So now I'm at 1. Okay, I'm trying to go to 2. Let's see. Oh. I turned on trace so you can see.
Oh,
so
and it's zooming in.
yeah, it's going down. So if you look, negative 36, and now it's up to positive 20 something.
Yeah.
So it jumps sides of the map.
Because it's slowly so high.
Yeah. So let's see if I could rearrange my thing again. And now let's try it again. Remember, just hit the number 2 and see if it works. And right here it says 2 undefined, and it gives me an asymptote there. Is that nice?
Yes.
Okay, good. Okay, so let's look at this right here. So for B, I don't know why I always use blue, but still. So B says this is and so the limit as x approaches 2 of g of x, this one limit does not exist. So for this one, the limit doesn't exist, so that means that it's not continuous. Okay, it has a discontinuity, so it is not continuous, no limit. All right, continuity at a number. Determine whether a function is continuous at a number. Okay, so this one's going to be x minus 2, 0, and 2. Okay, so the trick to this one right here, I showed you guys, I think the first week. Okay, square root of x squared plus 2. Okay, so I'm going to show you guys the trick on this. Go tab, back up to my problem. So square root x squared was, it said plus 2, right?
Yeah.
Could you not do that? All right, so and it was over x squared minus 4, right?
Yeah.
Okay, hit enter, and I'm going to change my window again. So here's how you change the window. Menu, window zoom, and let's just do standard. I don't have to make it too complicated. All right, so let's take a look. Now, I have this here, but now we're actually going to test numbers here also. We're going to test some numbers. So watch. So now I'm going out of this to the regular scratch pad. Going to the regular scratch pad, so this is where we're at now. And so vars. Remember we put our function in F1, right? Okay, enter. And so I want to test what number? What was the first number? Negative 2. Negative 2. Enter. It is undefined. So is that one continuous? No. Very good. So do it again. 0. So next one is at 0. Is that one continuous? At 0, is it continuous? Let's go back to our graph just to verify this. Now, here's 0 right here, right? So is the left hand and the right hand both going to that number? Yes. Is it existing at that number? Yes. There's no holes, no nothing. Okay, so it is going to exist at that number. So f of c does exist, right? And it is at that number. Okay, so let's go back. What was my next one?
2.
So positive 2, undefined, so that means that what? It is not continuous. So let's go through and fill this in.
So continuous is when everything is
All 3, yes. Left hand, right hand go to the same number, so the limit exists, right? And f of c is the number, it's equal to the number of the limit. Okay? So we said at negative 2, this is not continuous. Okay, 0 is continuous. And positive 2 is not continuous. Yes? Yes. Okay, good. Okay, here's that graph again. Alright, so we're going to determine whether a piecewise function is continuous. Okay? So, for this to work, I have to do some math. You know, I'm going to show you the math way first, then I'm going to show you the calculator way. So the math way, for it to be continuous, all 3 points have to be, or all 3 parts of this piecewise have to be the same number. Okay? So for x is less than 3, so I'm going to plug in 3 to the top. So if I plug in 3 to the top, what do I get? So 0 over 0. I don't really like that one, right? Okay, so now when x is equal to 3, I get 9. Okay, there's no function. It's just basically a constant, right? It's just going to be 9. And when x is greater than 3, what do we get? You get what?
6.
Okay, so it's going to be 6. So, what is that telling me? It's asking, is it continuous?
No.
No, because all 3 of these have to all go to the same number. Okay, all 3 points need to, or parts of this piecewise go to the same number. Now, let's take a look at the graph of how this is going to look. Did I do it on the next page? No. Okay, so, let's see, I'm going to need some help on this one so I don't mess this one up. All right, so hit tab, go up. Now, I'm going to go to, see this right here, this thing next, down below delete? This is the insert tools for right here. And I want a 3 by piecewise. It's this one right here. So make sure you click the right one. Okay, number of piecewise, okay, 3. Okay, so put my fraction, control, divide. That was, what was it? X squared? Over x minus 3?
Yeah.
Okay. And this is when x is, now, right here below the control, so control equal, and you want less than, right? 3. Let's go to the next part. It's constant 9 when x is equal to 3. And the last one is x squared minus 3. Okay, so let's see what it looks like now.
When x is
Oh yeah, thank you. When x is greater than 3. Enter. There we go. And I'm going to zoom out a little bit there. Let's move this over. Okay, so it looks like it is going to that, right? So what does it mean about that first part? If I ended up with 0 over 0, right? What does it mean about this first part of this function right here? What can I do? It doesn't look like it should be 0 over 0, right? What happened? What is x squared minus 9?
9 minus 3.
X squared minus 9. Can I factor that?
Oh,
Yes.
yeah, you can.
It's a difference of squares, isn't it?
Yeah.
It is. It's a minus sign there. X squared is a perfect square. 9 is a perfect square. So you're going to get x plus 3 and x minus 3. So if there's an x minus 3, isn't the x minus 3 on the bottom going to cancel that out? Yes. So when I did this, right here, so the top came out to be x plus 3, x minus 3 over x minus 3. And what happened to those x minus 3s? They canceled. So now, when I plug that in, what did I get? I get what? 6. So this one right here came out to be 6, didn't it?
So does that mean like?
Oh, so they are
pathways wrong?
contiguous.
Are they? Do all 3 go to the same number?
Go to 9.
This one goes to 6, this one goes to 6, but this one goes to 9. So,
So they all 3. I thought they were
all
trying
3,
to meet the
all
middle
3.
point.
So the limit will exist because the left hand and the right hand both go to the same
okay.
number. But is that number my f of c? No. So let's take a look at that graph again. So I'm going to turn on trace so you guys can see this right here. So menu, trace, graph. All right, so it looks good here, right? It looks like it just keeps going, doesn't it?
Yeah.
Okay, so now trace is on, but let's see what happens when I just hit the number 3. Uh-oh, it's off my graph, isn't it? That is not on my graph. So since this one right here is not on my graph, that means it is not continuous. That means that this corner right here has a hole. There's a hole there. So remember, roller coaster. If there is a hole, it is not continuous. Discontinuous. Okay? That's what we're going for. Discontinuity. So is this going to be continuous? Not continuous, right?
No.
There we go. All right, I think that's it for today. Yeah.
So like, if all 3 of them were to go to 6, it would be continuous.
It would be continuous. That means all points and the function are all at the same place.
6, 6, 6.
Okay. All right. So don't forget, like and subscribe, right?
No. Yeah.
Smash that like button.
No.
Turn your alerts on.